Hello, Namaste. This is Nikhil and welcome you to the Leo Samurai Learning Platform. And in this video series, we are going to learn the series solution of ordinary differential equation and these special functions. A part of this concept, today we are going to learn what do you mean by the ordinary differential equation, what do you mean by the solution of ordinary differential equations, and what are the different types of ordinary differential equations, and what are the different methods to find the solution of ordinary differential equations, and some basic concepts which are needed to find the solution of ordinary differential equation, like what do you mean by ordinary point and singular point and types of singular points and so on. Chaliye guys, without any further delay, let's move into the concept and let's complete today's task. Ordinary differential equation. Let's start with ordinary differential equation, right? Ordinary differential equation. In the word itself, the equate. I mean, we can realize that it is an equation which consists of derivatives. So, ordinary differential equation is an equation which consists of one or several derivatives of unknown function, which we usually call it as y of x. See, y of x is an unknown function, right? And we need to derive. I mean, it is the equation which consists of derivatives of this unknown function. That is, if we derivate for one time, that is called y of x. Sorry, y dash of x. For two times, then it is y double dash of x. So, right? So, this is the combination of these all, or y triple dash. The combination of these all derivatives is known as the differential equation. But here ordinary, the word ordinary distinguishes us from the partial derivation. बस उतना ही, उससे ज़्यादा कुछ नहीं है, ठीक है ना? And coming to the, let me give an example of ordinary differential equation. Y double dash plus 6y dash plus 3y equal to 0. It is an example of ordinary differential equation of order 2. Right? And let me tell you what do you mean by the solution of ordinary differential equation. See, guys, before going to know the solution of ordinary differential equation, let us assume that 2x plus 5 equal to 2x plus 6 equal to 3. ठीक है ना? This is a linear equation in variable x, right? So what we used to do to find the value of x, we do 2x equal to 3 minus 6, that is equal to x equal to minus 3 by 2. So what we used to say, x equal to minus 3 by 2 is a value which satisfies this equation, right? If we substitute x equal to minus 3 by 2, then this equation will be satisfied. That is nothing but x equal to minus 3 by 2 is the solution of the given linear equation in variable x, right? In the same way, in the differential equation, we need to find the value. See guys, y double dash of x. I will write in this form. d2y. Let's take easy one. dy by dx equal to x. It is a differential equation, right? So, for this, we need to find the value of y such that it satisfies this given equation. That is called as the solution. So, in detail, the solution of ordinary differential equation is a function or a curve or the set of family of curve which satisfies the given differential equation is known as the solution of ordinary differential equation. Yeah, don't panic, we all learned this in class 12 itself, in intermediate, I mean in class 12 integration chapter. I think many of you are familiar with this, right? Y equal to integral 5x plus 2 dx, that is 5x squared by 2 plus 2x plus c. This is what we did in class 12. This is the solution of the given differential equation. So I will write this as dy by dx equal to 5x plus 2. We can write this as this, right? So we find the value of y. If we substitute the value of y here, then the equation will be satisfied. There is nothing but y equal to 5x square by 2 plus 2x plus c is the solution of this differential equation. That's it. And now let's discuss what are the different types of ordinary differential equation, what are the different forms of standard forms of ordinary differential equations. Ordinary differential differential equation. Ordinary differential equations are mainly of two types. Ordinary differential equation with constant coefficient and ordinary differential equation with variable coefficient. Ordinary differential equation with variable coefficient. By the term itself, we can realize that what is the difference between the ordinary differential equation with constant coefficient and with a variable coefficient. I will give you an example for this. Y double dash plus 6y dash plus 3y equal to 0 is an ordinary differential equation with constant coefficient because all the derivative terms are headed with constant. I mean the coefficients are all constants. So this is known as the constant ordinary differential equation with constant coefficient. And coming to the ordinary differential equation with variable coefficient, y double dash plus e power x y dash plus 3 x y equal to 0. It is an ordinary differential equation with variable coefficient because we here the coefficients of derivatives are of variable terms, right? And in this video, in this chapter, we are going to focus and we are going to learn how to find the solution of this type of equations. I mean variable coefficient wala ordinary differential equation ka solution we are going to find. And it is little more complicated to find the solution of ordinary differential equation with variable coefficient comparing to the constant coefficient. And the equation will be in terms of series. Solution will be in series. चलिए, let's discuss ordinary differential equation with variable coefficient. Ordinary differential equation with variable coefficient. There are two standard forms of ordinary differential equation with variable coefficient. They are x square y double dash plus x y dash plus x square minus n square into y equal to 0. It is one of the standard form which we used to come across in ordinary differential equation with variable coefficient. And another standard form is 1 minus x square into y double dash minus 2xy dash plus n into n plus 1 into y equal to 0. It is another standard form which we used to come across in ordinary differential equation with variable coefficient when we used to solve those solutions, right? And this equation is known as Bessel's equation, and this equation is known as Legendre's equation. Legendre's equation. And the solution of this Bessel's equation is known as Bessel's function. Bessel's function, because the solution will be in the form of f of x, y of x, like that. It will be in the form of function. So it is known as Bessel's function. In the same way, the solution of this Legendre's equation is known as Legendre's function. And to solve these ordinary differential equations with variable coefficient, there are two main standard methods. One is power series method. Power series method. And another method is Frobenius method. Frobenius method. These two are standard methods which we use to solve the ordinary differential equation with a variable coefficient. And before going to solve this type of question, we need to know some of the basic concepts. And that is, ज़्यादा तो नहीं है, थोड़ा है. We need to learn what do you mean by ordinary point and regular point. That is the first step to find the solution of ordinary differential equation with variable coefficient. Before going to learn about the standard ordinary point and a regular singular point, let's know the standard form of an equation which we use in this chapter. Y double dash of x plus p of x y dash plus q of x y equal to 0. This is the standard form of second order differential equation with variable coefficient where p of x and q of x are the variable terms. And now let's discuss what do you mean by ordinary point and singular point. Ordinary point and singular point. For ordinary point, p of x naught should be a finite value and q of x naught should also a finite value. Here x naught is any positive integer which we substitute in p of x such that we need to get a finite value, not an infinite value. If we get p of x naught and q of x naught as a finite values at a particular positive integer x naught, then the point is called as ordinary point to the given differential equation. And coming to the singular point, p of x naught can be infinite or q of x naught can be infinite. दोनों में से एक भी होना चाहिए. If one of the p of x naught and q of x naught is infinite or both are infinite, then the point is said to be the singular point to the given ordinary differential equation. Okay, right? And what is the purpose of finding this ordinary point and singular point to the given ordinary differential equation? The reason is, if x equal to x naught is an ordinary point to the given differential equation, then there exists two linearly independent solutions to the given ordinary differential equation in the form of power series y equal to summation x equal to 0 to infinity cn into x minus x naught power n. And this is the base formula which we use to solve the differential equation when we take ordinary point as a reference. And we used to find y dash and we used to find y double dash, and we substitute this y dash and y double dash in the given ordinary differential equation, and further we move on to find the solution in the form of power series. This all we discuss in the next upcoming videos. And coming to the singular point, if x equal to x naught is a singular point, regular singular point to the given ordinary differential equation, then there exists at least one non-zero solution for the given differential equation, and this in the form of y equal to summation n equal to 0 to infinity cn into x minus x naught power n plus r. And same, we used to find y dash and we used to find y double dash, and we used to substitute in the given ordinary differential equation, and we used to find the a series equation which constitutes the solution. And coming to the singular points are of two types. One is a regular singular point and another one is irregular singular point. Singular points are of two types. Regular singular point and irregular singular point. Regular and irregular. Regular singular points are the points in which x minus x naught into p of x and x minus x naught into q of x both should be finite values. Then the point is said to be regular singular point. If one of this is infinite, then it is called as irregular singular point. Okay? Let's solve one of the question to get clear about the ordinary point and singular point. 2x square y double dash plus 7x into x plus 1 into y dash minus 3y equal to 0 is a given differential equation, right? So first what we need to do, whether we need to check whether it is in the standard form or not. If not, then we need to change it into the standard form. This is the standard form. So what we need to do, we need to divide the whole equation with 2x square, y double dash plus 7x into x plus 1 divided by 2x square y dash minus 3 divided by 2x square y equal to 0. Fine, cancelled. So what we get, y double dash plus 7 into x plus 1 by 2x y dash plus minus 3y 2x square y equal to 0. प्लस इंटू माइनस माइनस हो जाएगा ना. So this is p of x and this is q of x. The question is, we need to check whether x equal to 0 and x equal to 1 are the ordinary point or singular point for the given differential equation. So first thing, we find the p of x and q of x, right? And now we need to check whether they are finite or infinite at the given values x equal to 0 and x equal to 1. So first find whether x naught equal to 0 is an ordinary point or singular point for the given differential equation. So first write p of x equal to 7 into x plus 1 by 2x and q of x equal to minus 3 by 2x square. So what we need to do, we need to substitute x का जगह x naught substitute करना पड़ेगा, that is 0. P of 0 is equal to 7 into 1 into 0, that is infinite, right? And q of 0 is equal to minus 3 by 0, that is infinite. So as p of x naught and q of x naught are infinite, then this x naught is said to be, x naught equal to 0 is said to be singular point, right? And let's check whether this singular point is a regular singular point or irregular singular point. For that, x minus x naught into p of x फाइंड करना पड़ेगा, और x minus x naught whole square q of x. x minus x naught तो 0 है, ठीक है, and then p of x is 7 into x plus 1 by x, then 2 and x 7x into x plus 1 divided by 2x, that is x has got cancelled, and 7 into, if you put 0, then it is 7 into 1 7 divided by 2, it is a finite value, right? It is a finite value. Let's find this. X minus x naught is 0, डायरेक्ट कर लेंगे, x square into minus 3 by 2 x square. X square x got cancelled, that is minus 3 by 2. It is also finite. So what we can conclude, the given x naught equal to 0 is a regular singular point, right? It is a regular singular point. In the same way, we need to find the value for the, we need to find x naught equal to 1, whether it is a singular point or regular or ordinary point. And if it is a singular point, then you need to find whether it is a regular singular point or irregular singular point. ठीक है? In the next video, let's discuss how to find the solution of ordinary differential equation with variable coefficient using the power series method and Frobenius method. Thank you.